we will take time to investigate the relationship between current and voltage. And at the end, we are going to have current voltage graphs. All right. So with that said, let me quickly pick my pen, and then do the needful, right? Before I continue, my returning subscribers, I want to thank you very much for being good friends. Then, my new subscribers, I want to urge you to find value in what we are doing. Learning is a continuous process, and I want you to join us in promoting this channel, right? Share with your networks, give us some thumbs up, all right, to increase our metrics. Don't forget to put the bell button so that each time content like these are uploaded, you will be notified firsthand. Remember to share with your numerous networks, with your friends, with your students. Oh yeah, thank you so much. Now we are going to take time to illustrate and explain in clear terms what this is all about. Practical investigating current voltage graphs. There are many ways, all right? There are many ways to investigate the relationship between current and potential difference. And one of such ways is using a resistor, okay? Look at it. We can use a resistor, we can use a bulb, we can use a diode, all right? So there are three ways, so to say, that can be used to investigate current voltage graphs. And by the time we do that, we will now see what the relationship between current and voltage is all about. So in this practical activity, it is important to take note of the following factors. One, or procedures. One is we have to measure and observe current and potential difference. Each of the components, be it a resistor, a bulb, or a diode, each time there is measurement going on, we must observe what is happening on the ammeter and what is also happening on the voltmeter. That's what it means. The second one is use appropriate apparatus and methods to we have done the first one. The second one we are on to the second one, which says use appropriate apparatus and methods to measure current and potential difference (PD) in each case. So that's what we're going to do. Then the first thing we are going to use to carry out this practical is a resistor. This is a schematic diagram that represents how this whole arrangement will be done, how the experiment will be done. That is what the diagram illustrates. So we are going to connect a resistor. Look at it. This is the resistor. We are going to connect a variable resistor. Variable resistor is here for certain adjustments of values. We are going to have an ammeter, that is this, and also have a voltmeter connected as shown in the diagram. Then the next thing we need to know is that there must be some sort of power supply, energy being supplying current to the circuit. Very, very interesting. So the next thing is for us to take note of this one at a time and then carry out the practical as instructed. Now let's see the steps we are going to take in doing this, because it is only by understanding these steps that we can actually do the right thing. Now the aim of the experiment, very, very important. We must understand why are we doing this. We are doing this to investigate the relationship, all right, between currents and the potential difference. That's the essence of this experiment. We want to know the relationship existing between current and the potential difference. When a resistor is connected, or when a bulb is connected, or when a diode is connected, That is the aim of these experiments. So we are going to go through these steps one at a time and then explain each of them the way it should be explained. The first one is, the first thing we need to do to carry out this experiment is to connect the circuit as shown in the first diagram, the diagram we saw before. That's how we're going to connect it, and we are making use of a resistor in this case. Alright, so we are making use of resistor in this case. The second step is to ensure that the power supply is set, alright, is set to 0 at the start. Before we start, we must ensure that the power supply, be it a battery, be it a cell, is set to 0 at the start. Then the second one is to record the reading of the voltmeter and the ammeter respectively. Of course, having set the power supply to 0 at the start, we must take readings of the voltmeter, the readings on the ammeter respectively, because the power supply is set to 0. When that is done, we use the variable resistor to adjust, to alter the potential difference. Okay, variable resistor is there to adjust, to alter the value of the potential difference. That's this step we are talking about. So we have taken care of this. We have discussed this. We have also discussed this, and we are now in this fourth point. Then the fifth point, we record the new readings on the voltmeter and ammeter after adjusting the value of the potential difference using a variable resistor. We now take new readings, right? New readings on the voltmeter and also on the ammeter respectively. When that is done, the next steps is we begin to repeat. We repeat the steps 3 to 4. From 3 to 4 we repeat, each time increasing the potential difference slightly. Each time we repeat 3 to 4, okay, we increase the potential difference slightly, not much, so to say, right? Okay, then after that we reverse the power supply. The power supply connections have to be reversed. If it has been this way, we need to reverse it the other way around. So that's what it means. Okay, and then repeat steps 2 to 6. By the time we reverse the connections of the power supply, we repeat steps 2, 3, 4, 5, 6, and that is where we're going to stop. If we do that, we now have clear values. We now have clear values to plot. It is time for us to plot a graph of currents, all right, against potential difference for each component. Components such as ammeter giving values for current and voltmeter giving values for what potential difference. That's what we are trying to say here. And then we repeat the experiment by replacing the fixed resistor, okay, with a bulb. The first one we did was with a resistor, the second one is going to be with a bulb, and the third one is going to be with a diode. That's how the experiment should be carried out for us to obtain the results we are expecting to obtain. And that is the meaning, to investigate the relationship between current and potential difference for a resistor and for a bulb or for a diode. Now in our next slide, we are going to see the values obtained. Boom! You see, great values obtained. When the potential difference is 0.5 volts, we have 0.05 ampere or amps. When the potential difference is 1.0 volts, the current is 0.1 amps. When the potential difference is 1.5 volts, the current is 0.15 amp. And then when the potential difference is 0.2 volts, the current is 0.2 amps, and so on and so forth. This ellipsis you see here shows that the values continues. All right, okay. So having said that, let us now see when the potential difference PD is plotted against current A or I. Let's see what the relationship would be. Of course, because that is the essence of this class. Let's see what it will be. Let's see in our next class, or rather in our next slide, we are going to see the relationship. Boom! Once again, we have a relationship between current and voltmeter. You can see current is plotted. Current here is plotted against potential difference, right? And a straight line graph from the origin, traversing from the origin from both negative side of the graph to the positive side of the graph. What does this tell us? Let us see. For a fixed resistor, the potential difference is directly proportional. That's what it means. For a fixed resistor, the potential difference, PD, is directly proportional to the current. That's what it means. Meaning, as the potential difference increases, current also increases. That's what it means. If the potential difference reduces, so to say, current will also reduce. That's what it means. Very simple. Doubling the amount of energy. Okay, let's see what happens. Doubling the amount of energy into the resistor results in a current twice as fast running through the resistor. This relationship is called Ohm's law. It's called what? Ohm's law. So if we remember, if we still recall what Ohm's law is all about, this is just the direct explanation and illustration of what Ohm's law is all about. And it's true because the resistor or the resistance of the resistor is fixed and does not change. A resistor is an ohmic conductor. That's another class. An ohmic conductor. What is an ohmic conductor? If I put a question mark here, what is an ohmic conductor? So let's see if we can answer this question. There is a question here. What is an ohmic conductor? And to address that quickly so that we don't leave it unanswered, an ohmic conductor is a conductor that obeys Ohm's law. So any conductor that obeys Ohm's law is referred to as an ohmic conductor. That's the meaning, so that we don't leave it unanswered. That has been taken care of. A resistor that obeys Ohm's law is referred to as an ohmic conductor because of this relationship we are seeing. Now, alright, having said that, let's look at how this plays out in our next slide. But before I delve into more details, let me quickly remind us, give us some thumbs up, also hit the bell button for constant notification, share with your friends, with your networks, with your colleagues, with your students. You might be helping somebody by sharing this, okay, with them. Remember to give us some thumbs up to increase our metrics. Don't forget to share with your friends. Subscribe, very, very important. Promote learning by subscribing. It doesn't take anything, doesn't cost much, nothing. It doesn't cost anything. So it just by just clicking the red button, subscribe button there, and you become a member of this great family. Learning continues because learning is a continuous process. Thank you. Now let's look at what we have in our next slide. Great. Thank you so much, because we know at this point in time we have come to the point we need to express some thank you so much. That is it. Kindly support this learning by watching, subscribing, liking, sharing, giving the video some thumbs up. We need it. Subscribe, alright? Subscribe and become part of this learning community. Thank you so much. See you in my next class. We'll be discussing how we can now replace a resistor with a bulb and then see what happens with the relationship we're going to get. Whether we're going to get something different from what we got in our first experiment, or we're going to get the same. After which we discuss if a diode is connected, what happens next. See you in my next class. I'll be linking it somewhere here. Okay, that video will be linked somewhere here or somewhere there for your learning pleasure. See you